Welcome back to the series. This is part 3, and it's the one that saves you from spending money on hardware that can't deliver. Today we're cutting through the hype around local AI, CPU, GPU, Mac M series, what actually runs, how fast, and at what cost. Before you install a single model, you need to pick the right path, and that starts with an honest look at the silicon under your desk. So let's start with the fundamentals. There are really only 3 numbers that decide whether a model runs well on your machine. First, memory, RAM or VRAM, that's the hard ceiling. If a 7B model quantized to 4 bits needs roughly 5 gigs, and you don't have 5 gigs free, it simply won't load. Second, memory bandwidth, how fast you can stream those weights. That's the real reason GPUs feel fast and CPUs feel sluggish. And third, raw compute. It matters less than you'd think because bandwidth almost always chokes first. With those 3 numbers in mind, your hardware basically falls into one of 3 buckets. Path A is the laptop you already own. 16 gigs of RAM, no GPU, and you'll get a usable 5 to 15 tokens per second on small quantized models. Path B is the sweet spot, a used RTX 3060 or better somewhere between $300 and $1,200, and suddenly you're running 7 to 14B models at 30 to 80 tokens per second. Path B prime is the Apple Silicon route, pricier up front, but that unified memory punches well above its weight. Pick the one that matches reality, not the one that matches your ambition. Let's start with Path A because honestly it's where most people should begin. On a CPU-only laptop, your best friends are the small ones. Phi 3.5 Mini and Llama 3.2 3B will give you a snappy 10 to 18 tokens per second. Push up to a quantized 7B like Mistral and you're down to 6 to 10, which is readable but not zippy. 2 practical truths here. More RAM beats a faster CPU every time, and Q4 quantization is the sweet spot. Smaller barely helps, larger barely fits, and turn on streaming output. Watching tokens appear feels twice as fast as waiting for a wall of text. Now, if you've got even a modest budget, a consumer NVIDIA card changes the game 5 to 10 times faster than CPU, and that's not marketing fluff. A used RTX 3060 with 12 gigs of VRAM runs a Llama 3.18B at around 50 tokens per second for under $300. Step up to a 3090 and you've got 24 gigs, enough headroom for 14B quantized models at 100 tokens a second. The 4090 and 5090 are where 70B becomes realistic, but you're paying for it. And yes, AMD's ROCm exists. It works, but expect more friction. Now here's the plot twist for a Linux-focused series. Apple Silicon is genuinely excellent at this. Because the M series uses unified memory, the GPU can address the entire RAM pool, so a 64-gig M2 Pro will happily run a 70B model that would choke a $2,000 PC. You pay for it in raw speed, a 4090 will out-token any Mac, but you win on memory headroom and power draw. We're talking 30 watts versus 350 for comparable inference, and the software side is solid. A Llama runs on metal and Apple's MLX framework keeps getting faster. But before you drop $2,000 on hardware, consider just renting one. Vast.ai runs a marketplace model where you can grab a 4090 for around 40 cents an hour. RunPod's a bit pricier, but the interface won't make you cry, and Lambda Labs is the grown-up option with reliable A100s and H100s when you need them. The honest pitch here, spend $5 running a 70B model for an evening before you commit to buying silicon. It's the cheapest way to find out whether you actually need what you think you need. Once you know what you want to run, the math for whether it fits is genuinely simple. Rule 1. Multiply parameters by bytes per parameter. FP16 is 2 bytes, Q8 is 1, Q4 is half, so a 7B model lands at roughly 14, 7, or 3.5 gigabytes depending on quantization. Rule 2. Add about 20% for the KV cache and context overhead. That puts a 7B Q4 model at 4 to 5 gigs of VRAM. Plan the headroom and you'll stop downloading models that crash on load. So let's ground all that math in real setups. An old 16-gig laptop will happily run Phi 3.5 Mini or Llama 3.2 3B at 10 to 15 tokens a second, slow but usable. An M2 MacBook handles 8B at Q4 in the 25 to 40 range. Step up to an M3 Max with 64 gigs and you can actually run a 70B model, though only at reading speed. On the GPU side, a 3060 pushes 8B FP16 past 50 tokens a second, and a 4090 gives you headroom to run multiple tasks at once. Find the row closest to your machine. That's your honest starting point. But before you pick a row, you need to know what you're actually working with. On Linux, free-h gives you total and available RAM in human-readable form. For NVIDIA cards, NVIDIA SMI with the query GPU flag tells you the exact VRAM in megabytes. That 12288 is your real budget, not what the box claimed. And on a Mac, System Profiler piped through grep memory shows your unified memory, which is both your RAM and your VRAM. Run these now, no guessing. Once you know your budget, the real question, should you actually buy a GPU? Honest answer, not always. Pull the trigger if you're using local AI daily, building RAG pipelines, or you genuinely need 30+ tokens per second. But if you're just curious or your CPU already runs Phi 3 fine for the occasional query, save your money. A weekend on a rented cloud GPU costs about $5. That's a lot of weekends before you break even on a 3090. And if you do decide to buy, avoid the traps I see every week. That bargain 6GB card? Useless beyond a 3B model. 12GB is the floor in 2026. Pre-RTX 30 series cards often lack proper FP16 acceleration, so they feel sluggish. Don't expect CPU cores to rescue you either. DDR4 tops out around 50 gigabytes a second, while an RTX 3060 pushes 360. And please check your PSU and airflow before dropping a 4090 into a decade-old case. Now, here's the good news. You don't need to buy anything to keep following along. Every part of this series ships with 2 tracks, a CPU path and a GPU path. The first 4 parts are universal. From Part 5 onward, CPU folks run smaller models like Llama 3.23B and Phi 3.5, while GPU folks step up to Llama 3.18B or Mistral 7B. By the final stretch, you're either building Ask My Docs Lite or the full Pro stack, same skills scaled to your hardware. So let's compress this whole episode into 5 things worth remembering. Memory is the hard ceiling. If it doesn't fit, it doesn't run, so calculate before you download. Bandwidth, not core count, decides your tokens per second. There are 3 valid paths, CPU, Consumer GPU, and Mac M series, and you should start with what's already on your desk. Don't buy a GPU until CPU genuinely fails you, and before you do, spend $5 on Vast.ai to try a 70B model for an evening. That single experiment will save you a lot of regret. And here's the cheat sheet. Pause the video, screenshot it, whatever works. The core formula on the left, parameters times bytes per parameter, then add 20% for context and KV cache. On the right, the picks. 12 gigs of VRAM is the practical floor, Q4 or KM is your default quantization, Llama 3.18B is the GPU sweet spot, and Phi 3.5 Mini is your friend if you're CPU only. 2 commands to remember, free-h and NVIDIA SMI. That's the whole episode on one screen. Next time we're rolling up our sleeves. Part 4 is setup day. Linux, GPU drivers, Docker. We do it once, we do it right, and we never think about it again for the next 20 episodes. 3 down, 21 to go. The foundations are almost in place. See you in Part 4.